everyone, welcome to my YouTube channel. Today we'll be talking about mathematical induction problems. Okay, use mathematical induction to prove the statement summation over n is equals to k is equals to 1 to n of 2k minus 1 whole square, which is equals to n into 2n minus 1 into 2n plus 1 divided by 3 for all n belongs to capital N. So this particular statement, we have to prove that this statement holds for all n belongs to capital N, that is set of natural numbers. Now for this, first we have to prove for n is equals to 1. So because it is in the summation format, we want to write it in normal numbers format. So what we will do, we will immediately substitute k is equals to 1 over here. So if you substitute k is equals to 1 over here, you will be getting 2 into 1 minus 1 whole square. So 2 into 1 is 2, minus 1 is 1, that is 1 whole square, plus 2 into, again k, in place of k you substitute 2, you will be getting 2 into 2 minus 1 whole square, that is 4 minus 1 whole square is equals to 3 square. Again in place of k you substitute 3, you will be getting it as 2 into 3, 6 minus 1 whole square, that is 5 square, plus so on. In place of k you substitute n, you will be getting 2 into n minus 1 whole square, which is equals to n into 2n minus 1 into 2n plus 1 divided by 3. Now this is our statement, that is 1 square plus 3 square plus 5 square plus so on till 2 into n minus 1 whole square is equals to n into 2n minus 1 into 2n plus 1 divided by 3. Okay, now this statement you have to prove that it is true for n is equals to 1. For that, just simply substitute n is equals to 1. If you substitute n is equal to 1 over here in this statement, if you substitute n is equals to 1, you will be getting 2 into 1 minus 1 whole square, that is 2 minus 1 whole square, which is equals to 1 square, which is equals to 1. Now RHS part you take 1 into 2 minus 1 into 2 plus 1 divided by 3, which is equals to 3 divided by 3, which is equals to 1. Now assume that S of n is true for n is equals to k. So we have to assume that S of n is true. The statement is true for n is equals to k. So if you assume that the statement is true for n is equals to k, that is S of k is equals to 1 square plus 3 square plus 5 square plus so on till 2 into k minus 1 whole square, which is equals to k into 2k minus 1 into 2k plus 1 divided by 3. Okay. Now we have to prove that S of n is true for n is equals to k plus 1. So here we have taken till k, here we will be taking till k plus 1 instead of k, that is 2 into k plus 1 minus 1, that means 2 into k plus 2 minus 1, that is plus 1, right? Okay, now you check it out. Now this whole term can be replaced with the LHS part of the equation 1, RHS part of the equation 1, that is k into 2k minus 1 into 2k plus 1 divided by 3 plus 2 into k plus 1 whole square. Okay, now 2 into k plus 1 you take common, you will be getting it as k into 2k minus 1 divided by 3 plus 2 into k plus 1 divided by 1. Now take the LCM and cross multiply and get the value as 2 into k square minus k plus 2 3s are 6 plus 3, okay, which is divided by 3. So which is equals to 2 into k plus 1 into 2 into k square plus 5k plus 3 divided by 3. Now we have to separate this 5k and we can write it as 2k plus 3k. Okay, we just have to factorize the term actually. For that we are separating it. So we will be getting as 2k square plus 2k plus 3k plus 3. Now you can take 2k common. You will be getting it as 2k into k plus 1 plus 3 into k plus 1 into 2k plus 1 divided by 3, which is equals to 2 into k plus 1 plus 2 into k plus 3 into k plus 1 divided by 3. Okay, we will be getting it as k plus 1 into 2k plus 1 into 2k plus 3 divided by 3. Okay, now this term you can write it as 2 into k plus 2 minus 1. Okay, now this, because plus 1 can be written as 2 minus 1, just we are writing this in the format to get in the format as k plus 1. Okay, we want k plus 1 in this term, so for that sake we are just making some manipulations. Next, 2k plus 3. Okay, now this 2k plus 3 can be written as 2k plus 2 plus 1. Now this can be written as 2 into k plus 1 minus 1, and this can be written as 2 into k plus 1 minus 1 into k plus 1 divided by 3. Okay, now if you check out, this statement is quite similar to the statement of RHS in the equation 1. That is this statement. Okay, now here, this statement. Okay, this statement, that is k into 2k minus 1 into 2k plus 1 divided by 3. Here we have, in place of k we have k plus 1, in place of k we have k plus 1, and here also in place of k we have k plus 1. Okay, here over here you will be getting plus 1. Okay, it's a plus 1. Okay, divide by 3, that is, now by this statement you can say that this is resembling it as RHS of k plus 1. Okay, sum of k plus 1 terms. So now you can say that the statement is true for n is equals to k plus 1. Then by the principle of mathematical induction, you can say that S of n is true for all n belongs to capital N. Thanks for watching. If you have any doubt, please do let me know in the comment section.